Good morning everyone. Welcome to my classroom. Welcome again to another math tutorial. Before watching this video, don't forget to subscribe. Today we are going to have a video lesson for a new lesson. I hope you are all fine and homes together with your parents and other family members. Kindly read our content and performance standard for you to be guided on what you should do and what is expected from you after this video lesson. Today we will be discussing how to solve the value of n or r and the number of combinations using the formula. Let's have our objective. At the end of the lesson, the students should be able to find the number of combinations of n objects taken r at a time, solve for the value of n or r in a combination, and value the concepts of combinations in solving real-life situations. In our previous video, we discussed the difference between a combination and permutation. In permutation, order does matter, while in combination, it is the choice of r things from a set of n things without replacement and when order does not matter. In formula, the combination of n objects taken r at a time is equal to n factorial over r factorial times the quantity n minus r factorial, wherein n is the number of objects and r is the number of objects you want to select. Let's have example 1. Solve the combination of 8 objects taken 4 at a time. For the given n is equal to 8, r is equal to 4. Let's substitute it in the formula. NCR is equal to n factorial over r factorial times the quantity n minus r factorial. It is equal to n factorial, which is 8 factorial, over 4 factorial, which is the value of r factorial, times the quantity n minus r, which is 8 minus 4 factorial. And 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 40,320 divided by 4 factorial times the quantity 8 minus 4 factorial is equal to 4 factorial. So we have 4 factorial times 4 factorial. And 4 factorial times 4 factorial is equal to 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. And that is equal to 24 times 24. And 24 times 24 is equal to 576. And 40,320 divided by 576 is equal to 70. Let's have example 2. Solve the combination of 11 objects taken 5 at a time. For the given, we have the value of n is equal to 11 and the value of r is equal to 5. Substitute it in the formula. NCR is equal to n factorial over r factorial times the quantity n minus r factorial. And that is equal to 11 factorial over 5 factorial times 11 minus 5 factorial is equal to 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is equal to 39,916,800 divided by 5 factorial times 11 minus 5 factorial is equal to 5 factorial times 6 factorial. And 5 factorial is equal to 5 times 4 times 3 times 2 times 1 times 6 factorial, which is equal to 6 times 5 times 4 times 3 times 2 times 1 is equal to 120 times 720. And 120 times 720 is 86,400. So 39,916,800 divided by 86,400 is equal to 462. Let's proceed to the next example. Solve the combination of 12 objects taken r at a time is equal to 792. Let's have the given. N equals 12 and CR is equal to 792 and the value of R is unknown. For the solutions, we're going to look for consecutive values to multiply. We're going to use first the value of n, which is 12, multiply to its consecutive lower value, and that is 11. So we have 12 times 11, and that is equal to 132, and 132 will be divided by the value of NCR, which is 792, and that is equal to 0.166. Since the value of the quotient cannot be transformed to its factorial form, we will continue multiplying for the next consecutive lower value, and that is 12 times 11 times 10 is equal to 1,322 divided by 792, and that is equal to 1.666. The value of the quotient cannot be transformed to its factorial form, so we will continue, and that is 12 times 11 times 10 times 9 is equal to 11,880 divided by 792, and that is equal to 15. Since 15 cannot also be transferred to factorial form, we will continue again multiplying, and that is 12 times 11 times 10 times 9 times 8 is equal to 95,040. And that is divided by 792, and that is equal to 120. Since 120 can be transformed into factorial form, so we can use 120, and 120 is equal to 1 times 2 times 3 times 4 times 5, and that is 120 is equivalent to 5 factorial, so the value of r is equal to 5. Let's discuss the next example. Solve the combination of 11 objects taken r at a time is equal to 165. Let's have the given. N equals 11, and CR is equal to 165, and the value of r is unknown. For the solutions, we will start at 11. So we have 11 times 10 is equal to 110 divided by the number of NCR, which is 165, and 110 divided by 165 is equal to 0.666. Since it cannot be transformed into factorial form, we will continue multiplying. So the next one will be 11 times 10 times 9 is equal to 990 divided by 165, and that is equal to 6. Since 6 can be transformed into factorial form, so we are going to use 6. And that is equal to 1 times 2 times 3, and that is equal to 3 factorial. So we have 6 is equal to 3 factorial, and the value of r is equal to 3. Now let's solve the next example. The combination of n objects taken 3 at a time is equal to 35. Let's have the given. NCR is equal to 35, the value of r is equal to 3, n is unknown. For the solutions, the first thing we need to do is to look for the value of r, which is 3. It indicates 3 consecutive factors, and that will be n times n minus 1 times n minus 2 divided by the value of r factorial, which is 3 factorial, is equal to 35 automatically divided by 1. And that is n times n minus 1 times n minus 2 divided by 3 factorial, which is 6, is equal to 35 divided by 1. By using cross multiplication, we will have n times n minus 1 times n minus 2 is equal to 35 times 6, and that is n times n minus 1 times n minus 2 is equal to 35 times 6 is 210. And n times n minus 1 times n minus 2 is equal to 5 times 6 times 7. You're going to look for 3 consecutive number that will be equal to 210. And that is 5 times 6 times 7. So n is equal to 7. Let's discuss the last example. Solve the combination of n objects taken 4 at a time is equal to 15. Let's have the given. NCR equals 15, the value of r is equal to 4, and the value of n is unknown. Since the value of r is equal to 4, it indicates 4 consecutive factors, and that will be n times n minus 1 times n minus 2 times n minus 3 divided by the value of r factorial, which is 4 factorial, is equal to 15 over 1. So, we have n times n minus 1 times n minus 2 times n minus 3 divided by 4 factorial, which is 4 times 3 times 2 times 1 is equal to 15 over 1. We have n times n minus 1 times n minus 2 times n minus 3 all over 24 is equal to 15 over 1. By using cross multiplication, we will have n times n minus 1 times n minus 2 times n minus 3 is equal to 15 times 24. And 15 times 24 is 360. You think of 4 consecutive number that will be equal to 360. And that is 3 times 4 times 5 times 6. So we have n times n minus 1 times n minus 2 times n minus 3 is equal to 3 times 4 times 5 times 6. So n is equal to 6. Now remember this, when your dreams are bigger than the places you find yourself in, sometimes you need to seek out your own reminders that there is more, and there is always more waiting for you on the other side of fear, by Elaine Welterot. Thank you for watching. Keep safe always. God bless us all. Bye-bye.